Hi, this is Mrs. Kelly, and in this video I'm going to show you about function machines and function notation. So here in the diagram we have a function machine. Notice that what goes into the machine is your input, and it goes through the function inside, and then it comes out as the output. So think of it as this way. You take X, you put it into the machine, you do a series of steps or rules in the function, however many they may be, and then whatever comes out is your output. Okay? There's some other names we've been using for input, so let's go through what those are. An input is also, you can consider that your independent variable. Okay? So you can also picture this almost like if it was on an axis. You know, the independent variable always goes on your x-axis, and that means, of course, the dependent variable will go on your y-axis. So it's exactly the same case here. So it's going to have an independent variable, which is also known as your input, and then it's going to go through the function. Yet again, I'm going to show that step. Through the function, and you're going to get your output. So that's going to give you your dependent variable. You can think of it this way. The dependent variable depends on whatever the input is, or your independent variable. So it makes sense that it would come after it goes through the function because it depends. See, it even has the word depends there. It depends on it, right? So that's your output. The other way we've been referring to these are the following. We also just call the input all your x values. And therefore your output will be all your y values. So what this really means is now we have a different way to call y. Instead of y, we can also just say f of x. So that means f is my function, where x is the input, and then the answer that you get is your y. Okay, so now we can use y or f of x, and that's how you say it. Okay, is the same as saying your y value. All right. The last thing to note here is that when you see f parentheses x in the middle, this does not mean multiply. This doesn't mean take f and multiply it by something called x. It means x is the input of a function, and then whatever happens as a result of all the work inside the function gives you your y. Okay? So be careful when you see any questions that say, you know, what does f of x mean? That's what it means. It means f is a function, x is the input, and what you get as your result is f of x, also known as y. Okay, so that's the anatomy of a function machine. Now let's actually practice some function machines. So here we have a doubling function. So we're going to practice putting a few inputs in here and see what happens with our output. So for my first one, I'm going to take the number 3, and I'm going to put 3 into the doubling function. Okay? And if I were to take 3 and double it, let's say I started with 3 objects, like 3 candy bars, and I doubled it, I would end up with my output, which is 6 candy bars. Sorry. Okay? Now, what does this mean? So if I end up with 3 and get to 6, the doubling function is taking whatever x is and multiplying it by 2. So you can also say this is a times 2 function. Another way you can say it is that whatever is in here is going to be 2 times x. Okay? And whatever you get out is your f of x or your y value. So let's do another number in this doubling function and see what we get. So what if I had another number, let's say 7, and I put it in the doubling function? Well, that would mean 2 times my input, or 2 times 7, And if I do the work, that's 14. So my output will be 14. Okay? Now I don't just have to put in positive numbers. Notice that 3 and 7 were both positive. I can also have my input be a negative number. So what if I had negative 4? If I plug negative 4 into the doubling function, it's going to be 2 times whatever the input is, negative 4. Now I do the steps to solve that. So 2 times negative 4 is negative 8. So my output is negative 8. Okay. Notice here that if my input is positive, my output is positive. Same thing here. Positive input gives me a positive output. But when I'm doubling, a negative input gives me a negative output. Okay? Next, we're going to do the squaring function. It's a similar idea, except now we're squaring whatever goes inside our function. So let's look at what happens there. So if I took my input was x and I wanted to square it, that would mean I would take x and multiply it by itself. Okay? That would mean x times x. Now we learned earlier in the year that x times x can be written in a shorter way with an exponent. So this is basically the x to the second power or the x squared function. Okay? So whatever my output is will be the result of multiplying the input by itself. So let's try some examples of that. Okay? So we have 3, for example. If I took 3 and I put it into the squaring function, what I'm really saying is that's 3 to the second power, which is 3 times 3, so my output will be 9. Let's do another example. Notice here that 3 is positive, so my output when I square it is positive. Now I'm going to try a negative input. So negative 4, for example, I'm going to put that in the squaring function. So that would be the same as 4 squared, which is 4 times 4, okay, which is equal to 16. So my output is 16. Okay, and since it was a negative 4 and a negative 4, they multiply negative times a negative to become a positive 16. So it's interesting to notice here that anything that's negative in my squaring function as an input goes through the squaring function, and after you do all the steps, comes out as a positive number. Okay? And now, let's move on to another example. Now, what if my function machine is a little bit more complex inside? I have now my squaring machine, instead of a squaring machine or doubling machine, the following machine, negative 3x plus 5. So it's the same idea. Whatever goes inside, if it's x, I'm going to take that, multiply it by 3, and then add 5 to it, and that's going to give me my output or my y. So let's try some numbers. When it's noted like this means the function, and this is your input. So you're going to use this and substitute it for x. Okay, so my mu equation will look like this if I drew the diagram. 2 is my input into this function, which tells me to do 3 times whatever my input is plus 5. So now I'm going to show the steps here. So it's going to be 3 times 2 plus 5. So all I've really done is substituted x with a 2, and now I'm going to do order of operations to guide me to the answer here inside the function. So negative 3 times 2 is a negative 6 plus 5, and then the last step is negative 6 plus 5 is negative 1. So my output is negative 1. So what we really just did was took 2, substituted it in place for x, and did all the work. We computed it, and we got our result, which was negative 1. Okay? So f of 2 is equal to -1. Okay, let's do one more example. And we'll make it the last one a little bit more complicated. So we have this big function machine here with 3 steps to do inside. So whatever x is, I'm going to say 2 times x squared plus 5x minus 3. And whatever I get after doing all the steps will become my f of x or my y for this function. So let's find what it will be if my input is -2. Notice here, however, I've been saying f of x, but I can use other letters besides f. So I can use, notice here, f or h or g or any other letters for that matter in place of f to represent my function. Okay? So it doesn't always have to be the letter f. Okay? So in this case, let's use h. h of -2, what will that mean? I will take -2 as my input. I'm going to put that into my function, which is h, my h function, which tells me to do the following. Okay? 2x squared plus 5x minus 3, and we're going to figure out what our output will be. All right, so in this h function right here, I'm going to substitute in -2 in place everywhere I see an x. So that's right here and here. So let's rewrite that with the x's in place and instead have -2. So -2 times -2 in parentheses squared. Notice that I'm keeping it neat by putting parentheses. Plus 5, and then in parentheses in place of x, -2, then finally minus 3. So now I'm thinking order of operations. I'll write it on the side so we don't forget. I want to tackle any parentheses first and exponents. These are the first things. So looking at this, I see an exponent right here, so I'm going to do this as my first step so that I can do the parentheses. So -2 squared means, this is my scratchwork center, -2 times -2 is equal to +4. Okay, so this is equal to 4. I keep the parentheses around it for right now. Plus 5 times -2 minus 3. I just brought everything else down. Now I've taken care of that. I'm going to go ahead and finish my multiplying steps here. 4 times 2 is 8, plus 5 times -2 is -10, and then I just bring down the minus 3. Okay, so what I have here is 8 plus -10, that's -2, minus 3 is equal to -5. So definitely a lot more work to show here because there are more steps inside the function to compute before we get our final answer is -5. Okay, so hopefully this clarifies for you not only how to use a function machine but how to compute it and use the function notation properly to solve functions in the proper format. Okay, thank you for watching.